Hey, welcome back to Mellow Labs. Recently, it was my friend Pyro's birthday, and unfortunately, because he lives in a different country, we couldn't celebrate together. But I wanted to do something that would let us celebrate together anyway, so during one of my Twitch live streams, I set up a fan that Pyro could turn on and off using livestream commands that would let him blow out a set of candles. I also wanted to give Pyro control over one of these twistable confetti cannons, so I made a mount that would put a worm gear motor down here and hold the whole thing together so that it can twist it and then pop off. And as you can tell, that didn't work very well. What I actually ended up doing is putting pressure on the part that I was supposed to be twisting, and that just made the shaft of the motor spin in place and do absolutely nothing. So that was disappointing. And then my partner decided it would be funny if they just put all the confetti into the fan and let Pyro turn it on. It actually worked pretty well, at least well enough for my ADHD brain to put two things together. If slow motor equals smoke poof, then fast motor equals big poof. That seems like sound logic. Also, if you'd like me to celebrate your birthday, you can support me over on Patreon. Yes, £5 a month does buy you my friendship. A while ago, I think I came across the perfect fan for this project, and it's one of these. So these are, as the name implies, ducted brushless high-speed fans that supposedly can go up to 100,000 RPM easy. I really highly doubt it, but they're only £18. You can get them in a variant of 12 volts and 24 volts. I'm going to go with 24 volts, and we'll wait for it to arrive. And whilst we wait for them to arrive, here's a message from my sponsor. JLC PCB. With 19 years of experience and 5 state-of-the-art factories, it's no wonder that over 5.4 million engineers across 180 plus countries rely on their reliable and affordable services. Getting started is easy. Simply upload your Gerber files, get an instant quote, and place your order within minutes. It's just that easy. Whether you're prototyping or producing in volume, JLC PCB offers unbeatable pricing with 1 to 8 layer PCBs starting from just $2. But it's not just affordability. JLC PCB delivers premium quality with lightning turnaround times. Your boards can be ready within as little as 24 hours. All thanks to their fully in-house production process, which ensures quality control at every stage. And right now, there's an exclusive offer where you can get 6-layer PCBs for just $5 with $30 off of your first order. If you're ready to take your electronic projects to the next level, visit JLC PCB. And a couple days later, it arrived, and it actually looks pretty good. Don't worry, it's not actually that big, I just can't have my face in the shot or the camera will try to focus on me, so let's focus on that. It actually looks pretty decent. As you can see, I've got the 12 volt version. I did have to replace the power input wires. The ones that were soldered on there originally didn't look like too good, so I just replaced them with my own, and I didn't have a good red wire, so instead I used yellow, but that indicates it's 12 volts, so that works for me. Right, let's play around with it. Okay, so I'm setting up my power supply to deliver 12 volts. And now I can twist this potentiometer and it goes brr. And that's already pushing a decent amount of air. I don't know how to test this properly. Okay, so I don't know how much use this is going to be, but I got my kitchen scale as some form of test. Let's see how much thrust it produces. First of all, how much does it weigh? 70 grams, not bad. Okay, I'm just gonna point it down towards the scale and just like see how much air is pushed onto it, I guess. Okay, I got 75 grams there. It can just about lift itself. Right, so now let's figure out how good it is at flinging confetti. I'm just gonna use this tube. Oh, it's just a little too big. I'll just hold it. This is probably not a great idea. I think it's all immediately gonna go into the fan. Okay, so I have no idea how well this is going to work, but I just poked some holes in this sticky note, and hopefully that doesn't look like it's going to pass enough air. Bigger holes. Alright, so hopefully that should now prevent the confetti going directly into the fan. And here we go. Am I putting it on the wrong side? Is this the sucky side? Oh, that's the sucky side. Oh wow, I really am that dumb. Okay, well that explains it. Okay, now I can put the confetti in. Okay. That went well and then immediately horribly wrong. What happened? Oh, a piece got sucked in to the back. Okay, so yeah, we're gonna need a mesh on both sides of this fan. Oh, I didn't even check how much power this pulls. Okay, so on full tilt, it's about 5.10 amps. How fast does it ramp up if I like set this on full and then just give it power? I mean, it's pretty fast, but it seems kind of slow. So I'm worried that all the confetti, when it's in there and the fan is ramping up, isn't going to go fully up. It's just going to like escape out the side before the fan has time to ramp up and get rid of it all. So let's experiment. Okay, I'm sure it's all going to get sucked into the bottom after it falls out again, but let's give it a go. See, that's not bad, but it does take a second for it to ramp up before it escapes. See, I want it to have like a presence when it goes off, right? Yeah, that doesn't have that. It doesn't have the kind of confetti everywhere presence, you know what I mean? Yeah, no, it all just flops out like I expected. Damn it. Okay, so after blowing myself for a while, you know what I meant, I discovered something. So if I put it down like this and then power it up, it sounds awful, but it doesn't actually produce any lift, which it doesn't have any air to suck up, but it does give the fan time to like speed up, and then watch this. It's an immediate puff of air. So I think if I just like put it down, restrict the airflow, and then pick it up with it running, the confetti will go poof. I want to try that. I mean, again, perfect until the very end where it all went horribly wrong. What happened? Does it still work? Oh, it does. Okay, cool. I've got a plan. I don't know where I left off, but I made this mount for the fan and this servo that opens and closes the back end of it, and then I got distracted because I didn't have a good servo tester, so then I made a good servo tester, and now we're here. So my servo tester is pretty cool. If you haven't seen the video, go watch it, but in short, it lets me open and close the servo, and also lets me set positions, and I can play between those two positions as well, and I can adjust the speed. It's pretty cool. Go check out the video. But yeah, for the most part, I just want to open and close it. So now, if I power on the fan and open... Oh my god, I did not expect that to work as good as it did. God damn. Alright, I'm gonna develop this into bigger and better. BRB. I have some good news. Maximum Bombastic, who is one of my Patreon members, decided he really wanted to know what the RPM of the motor is, so he bought me a digital tactometer. He also bought me this shirt. But yeah, this should be able to tell me the RPM of the motor. And if I look through the instructions... Okay, it doesn't actually tell me how to use it though. Okay, so apparently these work on contrast, so if I just like paint a line here of black, it should work. Hopefully that's enough. I'm not recording on this camera. Okay, so I think the maximum there was 88,000, which is pretty good. But it's not 100,000. Okay, so after doing some very quick ChatGPT calculations, it might be that the claim of 100,000 RPM from this fan comes from it being under a vacuum. Because I basically just gave ChatGPT what I'm getting at normal atmospheric results, and I asked it what it would be like. It's all very speculative, and it probably has hallucinated everything. Doesn't matter. But it suspects, under vacuum, this fan could be from 95,000 RPM to 106,000 RPM. So, possibly under vacuum, 100,000 RPM. But we are not under vacuum, so I guess it's only a 87,000 RPM Confetti Canon. I'm still going to use 100,000 in the title. Okay, so I had an idea to go with a different method of preventing the air from getting into the back of the fan. I decided to try a butterfly valve, and I went through a couple iterations, and it doesn't quite work as well as I need it to. There's still a lot of air going past it. So I've got the butterfly valve there, and that can be opened and closed. The problem is that it doesn't actually stop air from going in. Like, I even printed these gates to like better seal against the whatchamacallit, the valve. And it just doesn't stop air from going through. So if I turn on the fan when it's not supposed to have any air coming out, yeah, that's pretty bad. So yeah, I played around with this idea for a little bit too long, I think, and yeah, I'm gonna go back to the sliding mechanism. That seemed to have worked really well. And that's exactly what I did. I went back to the sliding mechanism. It seems to work just fine like that. I wasn't able to test it with the fan because I finished it pretty late last night, so let's test it out. So I've got the fan in there, I've got all that. I've also printed out this kind of confetti holder. It's got a mesh at the bottom. I just didn't print that part with any top and bottom layers, so it's a mesh. Nice. I also have this cone, which we'll experiment with later. Let's put some confetti in here. I will say filling this one up with confetti is infuriating. Like with this one, it's pretty easy because it's got a wider thing and it just kind of slides in there. With this one, you have to like jam it in there, and because your fingers are covered in oils, the confetti just sticks to you, and it's kind of infuriating. Okay, let's test the fan. Wait, am I open? Nope, I'm closed. Let's do that. It seems to work. Okay, let's, ooh, wait, close it. Put that on. Oh, this doesn't attach in any kind of good way. It just sits on top, so I might have to hold it. Okay, power. Okay, that's pretty good. That's pretty satisfying. There's confetti everywhere, which is kind of the point. Right, I want to try this one. And oh, I didn't print this one with a mesh at the bottom, so it's all just gonna go directly into the fan, but hopefully that's not a problem. Okay, that's in there. Are we closed? Close. Oh, there's still confetti in the fan. Fan. That seems pretty good. Yeah. Okay, so I think what I need to do now is I need to work on the electronics. I've been kind of ignoring it because it's been working pretty well with my servo tester, but I need to make some kind of control electronic stuff for this. So I'm thinking relay for the fan, and then like a D1 mini just to like control the relay and the servo. Oh, I'm gonna need a step-down converter and all that. Okay, I'll do the electronics and then I'll explain them after. BRB. Okay, so this might look like a mess, but this is a good mess. This is mess of progress. So I've got my D1 Mini ESP8266 clone here that's doing all the fancy stuff. I kind of just vibe coded a script that lets me turn on and off the relay and move the servo back and forth. I've got a back boost converter which steps down the 12 volts into 5 volts for the relay microcontroller and servo, and then I've got another 12 volt lead that goes into the actual fan, which is controlled by the relay. So let's test it out. Like I said, it's a very basic script. It just moves the servo back and forth. It doesn't even go all the way. That might be a problem, but this is just a test. This is fine. And then we've got the on and off switch for the relay. It won't turn off. It won't turn off. I'm not quite sure what happened there. The servo still works. Okay, so it works again. Oh, it browns out immediately after turning on the fan. Okay, well that kind of makes sense. It's basically just sucking up all of the power available to it. Okay, capacitors. That's what capacitors are for. I'll try a small one. And if that doesn't work, I'll try a bigger one. Okay, well that's like somewhat nestled in there. Let's turn the power on again. Will it come back? Uh-oh. Ah. I believe I have wired the capacitor backwards. Yep, I'll get the window. Okay, so it turns out that the white marking on the capacitor is actually for the ground. Who would have thought? Okay, let's plug that in, and hopefully now it shouldn't do that. Is it working? It is! Okay, servo works. Very nice. And can we turn the fan on without it browning out? We can! Okay, what happens if I turn the speed up to like max where it's normally supposed to be? It still works! Okay, the capacitor helped. Sweet, okay. So with everything working as it's supposed to now, my next moves are to make an enclosure that will hold all of this together in a nice neat package, and and upload ESP Home onto this so that I can actually control it through Home Assistant. I'm probably just going to have it be a hard-coded thing to turn on the servo, turn on the fan, open servo, close servo, turn off fan, so that I don't have to, you know, mess with timings and stuff like that. Okay, let's go and do those things. So after I finalized my models, I started printing it on my Prusa Mini using Polymaker's Polylite PLA, which they very kindly sent to me. It's been printing great, no issues so far. And then I immediately moved on to assembly, where I realized that I've made a bit of a blunder. I made a hole for the fan cables to go through, and then didn't actually leave enough space for the potentiometer that controls the fan speed to fit through it. So I had to cut it with a hot knife in order to actually get the cables into it. I then proceeded to remove the heat press inserts from my previous design to put them into the new one. Now, I really respect CNC Kitchen, but I don't need a fancy doodad in order to take out my heat press inserts. I just stick my soldering iron into them and pull them out at an angle, and that's worked for me just the whole time I've had heat press inserts, honestly. I've been reusing these same ones over and over. Now, technically, these are not the ones for 3D printing. These are the ones for injection molding. But with a little bit of ingenuity, they work just as well. From there, I could move on to the electronics. I started off by putting in the fan, and then I screwed in the servo. Now, I went with the Metal Gear version of the servo, not because the blue one had any issues opening and closing. I just think it would be a little bit better for longevity, so that's why I did that. Then I moved on to the rest of the electronics. I basically just recreated what I did earlier, but on a smaller and tighter scale, just making all the wires shorter, really. And it managed to get everything just about fit in there. It is quite the squeeze. I didn't add any kind of dividers or separators, so at some point in time it will probably short circuit and cause a little fire, but you know, was a little bit of danger. Now, obviously, after I finished all the electronics, I didn't test them. I just closed up the enclosure and then went to test, and then realized that I actually connected the fan to the wrong terminal on the relay. Instead of connecting it to normally open, I connected it to normally closed. So as soon as you apply power, the fan turns on, so that was fun. So I had to open up the enclosure, switch the relay terminals, and then I realized, oh, I actually didn't install esphome on the microcontroller just yet, so I would have had to open it anyway. So I installed esphome, I closed it back up, I did a quick little test, and then I realized, oh, the motor's not actually running at the speed it's supposed to be running. So I had to open it back up, check the potentiometer to make sure it's on full throttle, and then I could finally close it and, you know, call this assembly finished. And now we can head over to the live action mellow for a conclusion. And here it is, like this is the main unit. We also have to attach the actual like funnel for the confetti, and I printed this little foot out so that I can have it at an angle. It does give it a little bit of top heaviness, but it kind of works. I might revisit this later, or maybe just add some more weight at the back, doesn't matter. Right, for power supply, I don't actually have a good enough power supply, so I'm just gonna continue using my benchtop power supply. And that should turn on, and my iPad's gonna die, so that's gonna be fun. We should have just enough battery life to actually get this demonstration done. Okay, so we have control over the servo. There we go. On and off. Yep, and then we have the relay. Beautiful. And I've also added a button that just does the whole shebang and trigger it. So if I press that, it is very loud. This is not going to surprise me at all, but I'll know it's coming. Okay, so let's fill it with confetti and see it do an actual poof. I did add the little filter at the bottom, but this time it's a gyroid, so that's nice. Right, my iPad is at 3%, so let's see it work. Oh, jeez. Okay, well, that didn't work very well, did it? I knew this stand was going to be problematic. Oh. Confetti. Okay, so I installed a tiny update. Basically, as soon as the fan ramped up and released, I pretty much closed the servo immediately. I just added a time delay there to maybe give it like an extra second of it being open. Hopefully that helps. Okay, let's make a mess. Yep, that did the job. That is a mess. Did something get sucked in? I don't think so. Yeah, I don't like this confetti. It just bunches up. When it's all small pieces, it's fine. When it's bunched up, it's not pretty. So it's still not as strong as I expect it to be. And I'm starting to think that the size of this air intake is actually causing me problems. Okay, hopefully that should do the job. Let's try that now. That does feel stronger. Right, ready, set. Yeah, that's a tangled confetti issue. I'm gonna get rid of the long pieces and just keep the small ones. Okay, I'm pretty sure livestream chat would also probably prefer the smaller ones because cleaning the map is a lot more annoying. Alright, it's filled up with tiny confetti. Final chance, let's go. That's kind of exactly what I wanted. That's perfect. Okay, tiny confetti. Maybe we'll just like chop up the small one, the long ones to make them smaller. I will need a guard on the back of that because I believe it sucked up a thing again. Also, maybe there's something we can do with like the geometry of the actual funnel. You know, we could make the air do weird swirly things. I don't know. I'm not an aerodynamicist. But with that, thank you very much for watching. Support me on Patreon if you can, if you want ad-free access to videos and early access and all that. And I will see you in the next one. Goodbye. Very good at cleaning up messes.